Hello everybody, that is here. Very happy to see all of you on the other side of the screen. Thank you for joining me, because today is the day when we will make a summarization video after testing all 7 water blocks, for which I already produced you with a number of installation tips video when we'll talk about the best way to install them and which mistakes can happen during installation, but we'll never talk about any test results coming out of all those activities, because I wanted to try all the blocks before making any kind of suggestions or make any kind of conclusions. I would like to say that this project was on the back of my mind for more than a year. I felt it was overdue to try to test number of water blocks available on the market back to back to see what they have to offer and is there any differences and things like this, because it became really a guessing game or some street rumors the way how you choose your block. But a few things was pushing the project away, and one of them was extremely high cost of producing of such a test results was a little bit burden for us. So for that note, I would like to thank you EK Waterblocks, Alpha Cool, Beats Power, Watercool, who's producing a heat killer, and Optimus Water Cooling for providing their blocks with no string attached to this project. And because of that, we was able to use our budget to actually purchase on our own dime 4090 for this test and all other equipment that required to do all the testing. So today we can talk actually about results coming of that. And on that note, I would like to share with you that during the testing process I actually realized that my approach a little bit changed from what I had in mind or envisioning in the beginning. Before the start of the project, I was thinking just to try all the block, check out what temperatures they're running, and basically to look into the best performing block on the market, and that was end of my target. But while trying the blocks just one after another, I figure out there's a number of factors that actually important and can change perspective or selection choice for the people when they're looking for the blocks, and which I also added to this test. So today I would like to look in all of that, and let's start with something that everybody expecting, which is temperatures. And of course I spoke a little bit too soon, because I just remember that every time I give you some numbers I have a number of people asking what was the testing environment. So to save myself typing a lot of text in the description, I spent 1 minute to tell you how I tested. So for the hardware portion of it, I utilized my test bench that I created for AM5 CPU block testing. It was the latest version of my test bench. It also was easiest to adapt to use it for GPU testing. Same motherboard, MSI Pro series with Ryzen 9 7900X, which was mildly overclocked, and I never touched it. It has Core 1 CPU block, which was the latest block I tested in my CPU blocks roundup, and the loop was really simple. It's just a triple radiator with D5. For the radiator, I specifically chose slim radiator dark side 27mm because I want to see what minimalistic scenario can work out. But my insurance was putting 3000 RPM fans on that radiator, which was Alpha Cool metal fans. But everything worked out great, and I was able to lower them to 2000 RPM, and it just stays 2000 RPM for the all tests I perform for every single block. D5 was set for speed 5, never touch it, so it was always maximum speed, end of the story. For the data collection I use 4 sensors. One sensor is Aqua Computer Flow Meter. It served me 2 purposes. One, it shows me flow rate, so I can compare which blocks is more restrictive, less restrictive. And second, it's collecting water temperature, which with the logging. So I could just record the water temperature over the time and see when the equilibrium was achieved. So for this test, I didn't run it, let's say, 40 minutes or 30 minutes for every block. I ran it until it became totally leveled. So that was a little bit different from my previous attempts. And also I have 3 temperature sensors, which allow me to see the delta inside of CPU blocks in and out, and delta inside of GPU blocks in and out the same. So I thought maybe it will be point of interest for comparison. Now, for the software, I decided to use two main scenarios. One scenario, traditional synthetic benching. Very stable load, and just we'll get numbers that we can compare between the blocks. But I also feel the synthetic benching is not a realistic thing. It applies maybe for 1% of the user who may be mining, maybe do artificial intelligence research, maybe do non-stop rendering or architectural stuff of 3D engineering, this kind of stuff. But most of us, come on, like the best you do in maybe gaming, the rest browsing internet and watching videos, it's a bullshit. It's not a lot. Nothing to compare here. So I decided for the second set of the test just to run one of the games I have. I used Cyberpunk 77, so I played a lot of it and I tried to achieve maximum temperature for each specific block that I use, all 7 of them. So it was a lot of hours of Cyberpunk playing. I think I'm pretty sick of it by now, but that was my approach. So now I can finally move to the first graph that we have. Let's remind you that inside of GPU we have access to 3 sensors. And GPU temperature, it's just average temperature between different sensors inside of GPU. We have hotspot, which is the highest temperature recorded inside of silicon, which is main chip basically. And we have memory junction temperature, which again, my understanding is the highest temperature inside of the memory chip, or one of the chips. Correct me if I'm wrong, but that's what I was able to dig out of internet, because there's not much information about how those sensors work. Also, it seems different from NVIDIA and for AMD specifically. So let's look at my first graph, which is GPU temperature for the non-overclocked version GPU, and we have a representation of Cinebench 2.0 and Cyberpunk. So if we look at this graph, just ignore for a second who is number 1, who is number 2. So you can see the Cinebench produce a little bit higher numbers. When we're gaming, we actually produce a little bit low numbers. Among all my temperature testing, that was basically the same scenario. So from the practical performance, if you decide to make such tests, realistically it makes no real difference in terms of who is better, who is worse. It just shows you a level of the heat that can be achieved by this method or other method. Now, let's look at the numbers. In this particular test, Optimus was absolute leader, both gaming or synthetic benching, followed by Heat Killer and EK Vector Active. So this is kind of leader group with Alpha Cool Core very close. And after that we have kind of a secondary group which consistently performed not as good, which is Ace Block, EK Vector and Beats Power. So although the delta between the best block and the lowest block is just 5 degrees, so it's not a lot. But if we go from the formal perspective, then basically that's how we have. We have a little bit better performing group and we have a little bit worse performing group. So another thing that I'd like to mention, that if you look on the Cyberpunk numbers, so you can see that a difference kind of shrink. So we only go to 2 degrees delta versus 5 degrees delta in a low heat output scenario. And also if you see the numbers that exactly the same, for example, we have Active, Core and Ice Block, which all 49 degrees. So essentially I have a numbers which has a number after decimal point, and that's how I use it to rank them out. So EK Vector was some fraction of degree better than Core, and Core was fraction of degree better than Ice Block. Let's look at my second graph, which is a little bit more interesting because I was able to also test air-cooled scenario for this particular situation. So when I overclock my GPU, I decide to run number of tests, and it's happened to be those tests that I use for the testing every single block. So now we have ability to compare stock air cooling versus water-cooled scenario with variety of the blocks I used. One thing that I need to mention that you can see is a little asterisk next to stock air cooling for the Cinebench 0 type of scenario, that's because unfortunately card run too hot and start thermal throttling. So it could be a little bit hotter, but we achieve 87 degrees maximum, and after that software put cap on that particular type of scenario. So realistically we can see that there's no actual difference between ranking of the blocks for this particular type of the test. We have Optimus on top and bit power on the bottom. Also our delta shrink to 4 degrees only, and for the gaming Optimus recorded 47 and bits power, actually that in this case it was EK vector which took the last spot, and it was only 3 degrees. So it doesn't matter if you overclock system or you not overclock system, essentially the ranking stays the same. It's just a question of what exactly number you get out of it. So let's move to the second type of the sensor we have available on this particular GPU, and this will be hotspot, which essentially similar type of scenario, just shows you what the hottest temperature was inside of the main chip by using the blocks that was tested. So looking at the first graph for non-overclock situation for the hotspot, we have pretty much the same type of the scenario. All the ratings stay exactly the same as we had with the previous sensor. The only difference that we actually have a little bit high temperatures. So Optimus has 51 degrees for the average temperature, but the hotspot became 61 degrees, so 10 degrees up, but the delta actually stays the same. So we have 5 degrees difference between bits power and Optimus in this kind of scenario, and the similar situation for the Cyberpunk gaming, just a little bit higher temperatures than we had before. In our clock scenario you can see that our hotspot temperature jumped another 10 degrees, so Optimus went all the way to 71 now, and bits power, which is the bottom of the list, went to 78. So our delta a little bit widened to 7 degrees, but now you can see why I have that asterisk next to stock air cooling, because the hotspot reached 104 degrees. And after that we run into the thermal throttling situation. Also air cooling worked just fine for the very long Cyberpunk gaming, and we can see that again the rating between the block, how they perform. We still have Optimus on top, and we have in this particular case EK vector passive which took the last spot. They was very close with bits power and keep kind of fighting for the last spot in my particular type of the test. So next one is very interesting. You will be really amazed. We need to switch to see what's going inside of the memory chips while doing the same test. So looking at the memory junction temperatures and non-overclock state, we have a few things going on here. First of all, I expected the lineup will be the same, doesn't matter what kind of test we're going on, what kind of sensor we're going on, but apparently everything gets shuffled quite a bit. EK vector took first spot, which I expected it to have be best everywhere, essentially because for the reason it's 2 GPU blocks on both sides of PCB. It's supposed to be the best, but no, it didn't work this way in the main core cooling. It wasn't the first, but we also have Optimus, who was the first, became the last. And we have a bits power jump in the middle of the list and barely worse than EK vector active. And for the gaming scenario it's actually literally the same as EK vector active, with just a fraction degree lower. So it was quite a strange. I think that the reason is happening is inside of the design of the blocks, but that probably required a separate investigation, which is outside of scope of this particular test. So let's look what's happening with overclock type of situation for the same type of the test for memory junction. On this graph we have air cooling back, so we can see the benefits of the water cooling comparing with the stock air cooling type of situation. Things shuffle one more time again. AlphaCool core actually worked really well in this particular scenario, somehow managed to went onto the first spot, while Heat Killer, EK active and bits power was basically sharing the second, third and fourth spot with only fraction of degree difference, and traditionally EK passive and ice block was kind of in the lower rank of my chart. And Optimus stays the last, so something going on here, we don't know, but whatever, it's happened. And with gaming we have the same situation with temperatures a little bit wider than we have in non-overclock state. So we have about, what, 6 degrees difference between alpha cool core 56 and 50 for the gaming versus synthetic benching. And interesting enough that in a gaming type of scenario we have a solid 30 degrees difference from air cooling, which absolutely amazing things to have. Now, after we look into the cooling performance of each particular blocks and see how they stack up against each other in my tests, I would like to bring you some additional data I collected during my testing, and I think some of it may be just equally impactful on your decision which block is right for you. So I have 6 things I would like to discuss in the end of this video and see if they maybe make sense for you. First data that I collected for myself, I tried to see what's the delta between liquid in and out from into the GPU block and out of GPU block, and I find no correlation between cooling performance situation, very similar to what we have with GPUs. It's about 1 degree all around, and I doesn't see this can be used as any meaningful type of the decision making process. Next thing I was looking into was the flow restrictions of each particular block, because flow rate may be impactful on the rest of your loop and you might be interested in that. So I measured that and I have a graph for you here. So what we have is the bits power is the least restrictive. A little bit surprising that Optimus comes second, and I expected it to be quite a restrictive block because cooling plate Optimus using is absolutely finest, the smallest slits, and I thought it probably will be very restrictive. So I think the size of it played a role here, so it was apparently very non-restrictive comparing with everybody else. And the rest of the blocks being progressively more restrictive, with alpha cool, both core and ice block will be the bottom of the list or being most restrictive. Maybe this make a difference for you, so I decided to make a graph for it. The second criteria I would like to bring your attention to is the weight of the block, because some of them are really heavy and can produce significant stress on your motherboard or your PCIe slot, depending on your design of course. But let's look at my graph. We have a bits power and ice block, which is relatively light with vector passive close to 1.5 kilo, and we go all the way to 2.2 kilograms, almost 2.3 kilograms for vector active, which is, I believe, around like 5 pounds. So you might consider using some sort of GPU support or post to make sure that you don't damage anything. Even during my test, I actually a little bit chipped some of the connectors on my 4090 because of keep yanking it's in and out, and also it was quite a bit of stress going throughout the PCB. I would like you to keep in mind when you select your GPU block and how you design things around it. The third factor I would like to discuss with you is easy of install. It's highly subjective thing, but I was in a unique opportunity where I was installing block one after other, so I have a proper feeling how hard or easy to install it comparing with other blocks in the lineup. And I can tell you that bits power was absolutely easiest block to install because thermal pads was already applied on the block, so it's basically the equation just slapping 2 parts together and put couple screws together. Alpha Cool also was very easy to install. Heatkit I would say was average, and Optimus was a little bit harder than others because it has a different type of the way you need to install the block, so you need to figure out how to deal with all those screws tightening, which I discussed in my installation video. And AK was absolutely hardest block to install, especially vector active, because it's 2 parts to it. You need to apply enormous amount of thermal pads which are very hard to peel. You need to cut them all by yourself, and also when you need to connect 2 parts together, the tightening of the terminal, installing the terminal was not easy process at all. So vector active quite a change even for experienced type of the builder. Moving along, I would like to bring your attention that some of the block generated issues which I consider important to keep in mind, and specifically if the bracket on the side of the GPU mounting bracket is attached to the block itself or it's not, because keeping in mind the problem with the high weight of most of the block in our lineup, the attachment to the block itself, for example how it's done on Alpha Cool blocks, actually reduce amount of stress on the PCB of the GPU itself, because you're stressing your motherboard, but also you're stressing your card just as well. And secondly, during the installation, if I notice or observed any type of the PCB deformation or warping. So looking at my graph, we have AlphaCool core, ice block, both AK blocks produce no issues because they didn't warp PCB and have attachment of the PCI bracket to the block itself. Heat killer didn't produce any warp, but it has no attachment to the block itself for the bracket, so you need to be mindful how you install it inside of your computer. And both Optimus and BitsPower, unfortunately, both have no attachment to the bracket and both produce GPU bending, which naturally it's not something you would like to see inside of your installation process. And the last but not the least factor in our discussion is the price of the blocks, how much you pay for what you get. And maybe for some of you it still doesn't matter, you throw whatever money on something that you really like visually or whatever other factor is important for you. More and more people start looking into the costing and what you're actually buying with your hard-earned cash. And if we look on my list, so that's quite an interesting conclusion that you can make out of it. For example, AlphaCool Ice Block has no issues performing relatively well, kind of middle to the lower part of the equation, and AK Vector Active, who probably performed more on the middle to upper part, not always on the top, is 2.5 times more expensive. So would you pay that? Maybe not. So that's up to you. We have also AlphaCool Core presenting excellent value because it's not very expensive and consistently was in the middle or upper part of the numbers. We have a Heat killer with consistently perform really well and kind of in the middle of the pack, and we have Optimus, kind of expensive, being top cooling block for the core while something going on with the memory, and it's a little bit expensive, but it's look awesome. So there's a lot of things that how you can slice the cat. I leave you with this graph to consider your options. We didn't discuss in this video any of my additional thoughts about those blocks, which I would like to make a separate video. This video only about test results. So thank you for watching. I hope you find it interesting. And thank you again for everybody who helped to make this test happen. I see you next time.